Good afternoon, dear students.
Good afternoon, sir.
Uh,
Good
Good
afternoon, sir.
afternoon.
I hope you can see the screen now.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
In the last period, my dear students, we have studied about the physical properties of this carboxylic acids. In these physical properties, we have studied first about their ability to form the hydrogen bonding. So carboxylic acid are able to form a good amount of hydrogen bonding due to the presence of oxygen and carbon, which have a good electronegativity difference. And if we look at the resonance structures, we will find that in the process of resonance, uh, my dear students, the electron from the double bond goes to oxygen. At the same time, the extra electron or the lone pair present on oxygen goes to the carbon and oxygen. So the carbon is directly bonded to the two different oxygen, and that is why this two different oxygen basically make the availability of oxygen very easily, and thus the double bond can be formed at any instance between the carbon and oxygen, and one oxygen has always got the negative charge. In this manner, the ability of carboxylic acid to release H plus is even more, and we can even understand that carboxylic acid can easily lose the hydrogen due to the stability, which is known as the resonance stability. The carboxylic acid, even in their vapor phase, please remember, my dear students, that even in their vapor phase, this carboxylic acid exists as a dimer, and that is why they have comparatively, their boiling points are even higher than the alcohols, aldehydes, ketones, and even the hydrocarbons. So this is how we can understand that their boiling points are comparatively higher. Even this carboxylic acid, they prepare the hydrogen bonding uh, with the water, and as the hydrogen bond is formed with the water, my dear students, they are much soluble or miscible in water. As this carbon chain that is present as an R here increases, the solubility of this carboxylic acid decreases, my dear students, up to uh, 9 carbon. All the carboxylic acids are liquid, but after ninth carbon, all the carboxylic acids are solid, but their solid structure is like waxy solid, and that is why these waxy solids are insoluble in water. And this is how we can understand the solubility of carboxylic acid. Aromatic aromatic carboxylic acid, the simplest aromatic carboxylic acid is benzoic acid, and it is also almost insoluble in cold water. Carboxylic acids are also soluble in less polar solvent like benzene, ethyl alcohol, and chlorophyll. Now, if you look, try to understand their acidic behavior, this carboxylic acid even reacts with the metal to produce hydrogen gas. Carboxylic acid reacts with base to produce salt and water. Carboxylic acid even produce carbon dioxide gas with the metal carbonate and metal bicarbonate. And this is one of the very important tests for the detection of the carboxylic acid, because alcohols and phenols, they can even produce hydrogen gas with the metal, but they cannot produce carbon dioxide gas with the metal. And this is how we can easily identify, or this is how we can easily understand that if a substance does not give carbon dioxide with the NaHCO3, it should be alcohol. But if the substance give both the reaction, that means if it produces hydrogen gas as well as it produces the carbon dioxide gas, then it must be a carboxylic acid. Or if we can simply taste by just doing the carboxylic acid test, that by doing the reaction with the metal carbonate and metal bicarbonate, that if the substance give metal carbonate, if substance gives carbon dioxide with the metal carbonate and bicarbonate, it is carboxylic acid. And if it does not give carbon dioxide gas with the metal carbonate and bicarbonate, then it must be an alcohol. So this is how it is very important test for either the distinguish between, or it is also very important for the identification of the various carboxylic acid by doing some test. Same way, my dear students, if we understand about the reaction of carboxylic acid with water, the stability of carboxylate ion is much more due to the resonance stability, and thus the reaction or the equilibrium always is towards the carboxylate ion, and that is why carboxylate ion is more stable as compared to the carboxylic acid. And we can say that carboxylic acids are acids. Now their acidity can be determined by the determining the value of pKa. Higher is the value of pKa, lower or less acidic is the substance. So those substances which are strong acids, they have their pH value less than 1, but the uh, moderately acidic substances or moderately strong acid have their pKa value ranging between 1 to 5. Weak acids have their pKa value ranging from 5 to 15, and extremely weak acid have their pKa value greater than 15. So this is how we understand about the acidity or pKa value for the various acids. Carboxylic acids are weaker than the mineral acids. So but they are stronger acids than the alcohols and many simple phenols. So carboxylic acids or their acidic strength is more than the acidic strength of alcohol, but it is less than the acidic strength of the mineral acids. Even they are more acidic than the phenols. So pKa value uh, for ethanol is approximately 16, and pKa value is approximately 10 for phenol, and on the basis of that we can easily understand that these carboxylic acids are better acids than the phenols and even the alcohols and phenol both. In fact, carboxylic acids are amongst the most acidic organic compounds. Please remember that no other organic compound is as acidic as the carboxylic acid. So they are the most acidic organic compounds among all the organic compounds. You have studied so far. You already know why phenols are more acidic than alcohols. The bigger acidity of a carboxylic acid as compared to the phenol can be understood similarly. How you can easily understand that the stability, if we compare, my dear students, then the carboxylic acid, as we have seen here, that carboxylic acid are less stable and carboxylate ion is more stable. Carboxylate ion is stable because of the two resonance structure, and even these two resonance structures have negative charge on oxygen, which is even provide more stability to them, and thus the stability of carboxylate ion is more than the stability of carboxylic acid, and that is why the carboxylic acids are more stable. Carboxylic acids are quite acidic. The stability of carboxylate ion is even more than the stability of the uh, phenoxide ion, and so, dear students, can you hear me? Hello.
Yes,
Yes.
sir.
Okay, okay, that's
Yes,
good.
sir.
Can you see the screen on your screen?
Yes, sir.
Good, good. Thank you for replying. So this is how the carboxylate ion are more stable than carboxylic acid, and they are more acidic. The carboxylate ions are even more stable than the ions produced by the phenol by losing the hydrogen. That is what it is known as the anion formed by phenol. And that is why carboxylic acid are more stable or more acidic, sorry, more acidic than the phenols. Uh, so compared to phenols, it can be understood similarly that carboxylic acids are more stable. The conjugate base of carboxylic acid, that is carboxylate ion, it's stabilized by the two equivalent resonance structures in which the negative charge is at the more negative oxygen atom, and this is how we understand the stability of the carboxylate ion. The conjugate base of phenol, that is a phenoxide ion, has non-equivalent resonance structures in which the negative charge is at the less electronegative carbon atom, and therefore resonance in phenoxide ion is not as important as it is in the carboxylate ion, whereas it is less effectively delocalized over one oxygen atom and less electronegative carbon atom in phenoxide ion. Thus, we can say that carboxylate ion is more stabilized than phenoxide ion. So, carboxylic acids are more acidic than phenol. So, even if you, in your exams you are asked the same question, you can answer this question by writing this text, that how you can explain the carboxylate ion is more stabilized as compared to the phenoxide ion, and that is why carboxylic acids are more acidic than the phenols. Uh, Effect of substituents on the acidity of the carboxylic acid. Now we want to study about the effect of the substituents that are present on the carboxylic acid. We can, my dear students, have various types of substituents. We can have electron withdrawing group as a substituents, and we can have electron donating group as a substituents, and how they affect the acidity. Let us understand one by one, my dear students. Effect of substituents on the acidity of the carboxylic acid. Substituents may affect the stability of the conjugate base and thus also affect the acidity of the carboxylic acid by stabilizing the conjugate base through delocalization of the negative charge by inductive or resonance effect. Conversely, electron donating group decreases the acidity by delocalizing the conjugate base. So here the simple funda that we can understand here, my dear student, is written over here very clearly with the green pen, that electron withdrawing group stabilizes the carboxylate ion and strengthen the acidic character, whereas the electron donating group destabilizes the carboxylate ion and weakens the acid. Let us understand this with little more discussion, my dear students. Let's have a look to this. See, if you think of the CH3COOH as an acid. Now, if you compare it with the HCOOH as an acid, you can easily understand, my dear students, that here with the carboxylic acid, hydrogen is bonded, whereas here with the carboxylic acid, CH3 group is bonded. My dear students, this CH3 group is an electron donating group. And that is why when the uh, acetic acid is formed or ethanoic acid is formed, and when we have the methanoic acid or formic acid, by the presence of the electron donating group CH3, we can easily say that the acidic character of formic acid is more than the ethanoic acid. Same way, my dear students, if the number of carbon increases, the acidity decreases. So we can say that CH3, CH2, COOH is even less acidic than the ethanoic acid. So as the number of carbon increases, acidic strength decreases. So as the number of carbon increases, acid strength decreases. Now, my dear students, we want to understand about something else. Suppose the same we have CS3 COOH, and we have one more compound where this CS3 is replaced, this hydrogen is replaced by one of the chlorine or fluorine atoms. So let's say this hydrogen is replaced with chlorine. So now the new compound that we have is Cl CH2 COOH. Now this chlorine is more electronegative than this carbon. So what happens? This chlorine will take the electron of this carbon towards it and make this carbon little more electropositive. And this is how, this is the electron withdrawing group. This CH3 is electron donating group. So the presence of this electron withdrawing group increases the acidity, and thus the chloroacetic acid is more acidic than normal acetic acid. Now my dear students, if we look at the electronegativity of the various halogen, we can find that fluorine is more electronegative than chlorine, chlorine is more electronegative than bromine, bromine is more electronegative than iodine. So now if we look at, let's not think much about iodine, and let's try to uh, study it in a different way. So just 1 minute, my dear students. Let me show you that if we have this fluorine, chlorine and bromine. Now suppose instead of chlorine, if we have, suppose instead of chlorine, my dear students, if we have fluorine bonded to it, let's say it's fluorine that being bonded to the, instead of this chlorine, suppose fluorine is bonded to the acetic acid, which is known as the fluoroacetic acid. So we can easily expect that fluoroacetic acid will be more acidic than the chloroacetic acid. Now my dear students, suppose we have chloroacetic acid ClCH2COOH, but we may have this even replaced by chlorine, so we can have even Cl2 CHCOOH, or even we can have Cl3 CCOOH. So we can have dichloroacetic acid, or we can have trichloroacetic acid. We can have dichloro as well as trichloroacetic acid. So we can easily understand that our dichloroacetic acid is more acidic than the monochloroacetic acid, and the trichloroacetic acid is even more acidic than the dichloroacetic acid. So as the number of halogen even increases, we can even increase the acidic character. Same way, my dear students, suppose we have this compound, that is propanoic acid. So we will have CH3 CH2 COOH. Now suppose we want to replace one of the hydrogen with the fluorine. So let us replace the hydrogen with the fluorine, and suppose we have replaced the second hydrogen, or the hydrogen of CH3 first with the fluorine. So now if we have FCH2, CH2, COOH. So it is monofluoro only, but this monofluoro will be more acidic than this propanoic acid. But now if we put this fluorine near to the carboxylic acid, if fluorine is on the second carbon, so this is 3 fluoro, 1, 2, 3. So if this is the 3 fluoro, if we think of the 2 fluoro carboxylic acid or 2 fluoropropanoic acid, we can say that more near is the halogen to the first carbon or carboxylic carbon, more will be acidic strength, and this is how we can understand that more, even in the monofluoro or monochloro, when we compare, more near is the fluorine or halogen, more will be its acidity. So now, my dear students, I hope you understand. I was trying to tell you how the acidic character increases with the carboxylic acid. Now let's study this uh, increasing acidic strength with few more examples and few more understanding, my dear students. Uh, Let us study the text so that we can understand it better. The effect of the following group in the increasing acidity order. So you can see that uh, phenyl group has the lowest effect, then iodine, then bromine, then chlorine, then fluorine. Even these are more effective, uh, cyanide and nitro and CF3. So effect of the following group in increasing acidity, you can see that thus the following acids are arranged in the increasing order of their acidic character. These all groups, my dear students, are the electron donating or withdrawing. What do you think? They are the electron withdrawing groups, and these all withdrawing groups increases the acidic strength, and thus, my dear students, the phenyl acetic acid or acetic acid with the aromatic ring will be more acidic than the aliphatic acids. So here you can easily understand that CF3 group, if it is bonded, it is the most highest acidic, then CCl3, then CHCl2, then NO2, then NC, that is CN. We are talking about the ethanoic acid, that is cyanide group, then fluoro in single, then chloro in single, then bromo in single, then our normal methanoic acid, and then this methanoic acid is even more acidic than the number of carbon if they are increased. But if there are two more carbons bonded, my dear students, and even in that case, when we have these two carbon bonded to it, which are electron donating group, but even if one electron withdrawing group chlorine is present, then it is even less acidic than methanoic acid. Then we can understand about the aromatic. So phenyl acetic acid is more than the the phenyl ring bonded to the carbon. So it is one phenyl acetic acid. Normal acetic acid is even less acidic than all these compounds, and propanoic acid is even less acidic than the ethanoic acid. So I hope, my dear students, after discussing all that, now you can understand this order, that the presence of the phenyl group even increases the acidic character. The normal acetic acid is less acidic than all these compounds. But if the number of carbon increases, that means acetic acid is even more acidic than the propanoic acid. So now I hope, my dear students, you understood this. If you have any doubt, अगर बच्चों ये जो एक्सप्लेनेशन मैंने दी उसमें से अगर आपको कुछ समझ में नहीं आया तो आप पूछ सकते हैं बच्चों.
No, sir.
आज सारी acidic strength, you understood everything about the acidic strength? If you have any doubt, you can ask me. Please reply, all of you. I'm expecting the responses from all of you, my dear students. Please,
No, sir.
please do not take more time to reply. I'm expecting the responses from all of you. Please, everybody, please unmute yourself and speak something.
No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
So should I believe that
No.
you understood everything? You understood the concept?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you for the wonderful replies, my dear students. Let's move forward and understand the further, or let us discuss further about carboxylic acid. Direct attachment of groups such as phenyl or vinyl to the carboxylic acid increases the acidity. Please remember that the direct attachment of the groups also increases the acidity, and this group should be either the phenyl or vinyl. So direct attachment of the groups like phenyl or vinyl increases the acidity. You can see here there is a double bond, and due to this double bond, the electron from the vinyl or electron from the double bond goes to the uh, carbon, and thus the double bond between these two carbon has been formed, and the double bond between carbon and oxygen has been broken. The oxygen has got the negative charge, and this is how we understand about the uh, um, joining of such such groups with the carboxylic acid, and how do they effect. So this is because the greater electronegativity of the sp2 hybridized carbon to which carbon bond to which carbonyl carbon is attached, the presence of electron withdrawing group on the phenyl or aromatic carboxylic acid increases their acidity, while the electron donating group decreases their acidity. So here if we think about the phenyl acetic acids, or sorry, the carb the carboxylic acids, in which the C double bond O group is directly bonded to the aromatic ring, my dear students. When the group is directly bonded to the aromatic ring, what happens? We get the benzoic acid. So if we have benzoic acid or its derivatives, let us understand and let us compare their acidic behavior. Now here we have benzoic acid. Benzoic acid is bonded to the OCH3 group. Benzoic acid is bonded to the NO2 group. This NO2 group is electron withdrawing group, my dear students. NO2 group is electron withdrawing group, whereas OCH3 group is electron donating group. So if there is electron donating group, my dear students, you can see that pK value is only 4.46. But when we have electron withdrawing group, my dear students, you can see that pK value is 3.41. And the pK value for benzoic acid is 4.90. So as the electron donating group is bonded to the phenyl ring, and if the electron withdrawing group is bonded to the phenyl ring, now you can easily understand what happens. In which case the acidity increases, or we can easily understand that more the pK value, less is the acidic strength. So when we have electron donating group bonded to it, the acidic strength decreases, but when we have electron withdrawing group bonded to the phenyl ring, acidic strength increases, and that is why we can write the order of acidic strength in this manner, that a nitrobenzoic acid or 4-nitrobenzoic acid will be more acidic than normal benzoic acid, and benzoic acid will be more acidic than 4-methoxybenzoic acid. So using this idea or using this knowledge, my dear students, we can solve the next problem where we can have the understanding of whatever we have studied. Which acid of each pair shown here would you expect to be stronger? CH3COOH or CH2FCOOH? Now you are supposed to answer this question, my dear students. Out of this, out of CH3COOH or CF2COOH, which one is going to be more acidic, my dear students? You need to tell me. बच्चों आपको बताना है. Can you tell me? बताएंगे क्या?
Yes, sir.
Which one is there?
Yes, sir.
See, here we have CH2FCOOH and CH3COOH. CH2FCOOH will be more acidic because it has got fluorine, which is electron donating group, sorry, electron withdrawing group, and this electron withdrawing group increases the acidic character, my dear students. Same way, if you compare the CH2F and CH2Cl, then chlorine and fluorine. Fluorine has got more electronegative than chlorine, and that is why, my dear students, the acid which has fluorine bonded to the first carbon will be more acidic than the chlorine bonded to the carbon. Same way, my dear students, here you can see the distance from the carbon. You can see that first, second, third and fourth carbon. Here fluorine is bonded to the fourth carbon. Here 1, 2, 3 and 4. Fluorine is bonded to the third carbon. So fluorine is more near here, whereas fluorine is quite far away. And that is why this compound is